Hey everybody, it's Dr. J, and today we're talking about heat capacity. Let's talk chemistry. All right, so we have heat capacity, and heat capacity is the quantity of heat required to change its temperature by 1 degree Celsius. Okay, so this is all about how much energy, right? How much heat is it going to take to change that temperature by 1 degree? Okay. So we have two types of heat capacity we're going to talk about today. Specific heat capacity. So this is the main one. The amount of heat energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So because it's by grams in Celsius, our units for specific heat capacity are going to be joules, right? That's our J, joules over grams times Celsius. Okay, so this is the units for specific heat capacity. We also have another heat capacity called molar heat capacity. So this is the amount of heat energy required to raise the temperature of 1 mole of a substance 1 degree Celsius. So instead of using grams, we use moles here. All right. Okay, so let's look at these examples of specific heat capacity. Just point out a couple here. So we have these metals over here with lower specific heat capacities, and what we can see, right, is that think of these metals as they're going to heat up very quickly, right, because they have low specific heat capacity. So with gold, right, it doesn't take much energy or heat at all to quickly heat up gold. In fact, gold, if you heat it up quick enough, it can actually melt, as we know, right? Compare that to water. Water has a very high specific heat capacity at 4.18, one of the highest. And because of this, right, it takes a lot of energy to raise the temperature of water, right? Anybody ever try to boil water and you got that water boiling forever, right? Because it takes a long time for that to actually heat up. Now, when we're talking about heat capacity, we have this equation over here, and this is going to be the main equation we're going to focus on today. Q equals M times C times delta T. So let's break this down to say which of these letters, what do they mean, all right? So Q, we all know right now that Q should be heat, right? Remember, Q is heat. Therefore, the units for Q, you should expect to see joules. So Q equals M. In this case, M, we're talking about mass. Usually this is going to be in grams. And then we got this CS. This C just means specific heat capacity. So each element, as we looked over here, has a specific heat capacity. And then it's multiplied by the change in temperature, right? The delta means change in temperature. And that's going to be given in Celsius for the most part. So let's say we got an example here. It takes 487.5 joules to heat 25 grams of copper from 25 degrees Celsius to 75 degrees Celsius. What is the specific heat in joules over grams Celsius, right? So now we need to figure out what's the specific heat in this case. So what are we going to do here, Dr. J? Well, we're going to do something like this. We're going to use our equation Q equals M times specific heat times change in temperature, right? So it says that it takes 487.5 joules. Well, joules is a giveaway. That's going to be my Q, right? So notice, right, what it's asking for, specific heat. So it might be an instance to where, you're not solving for your energy, you're solving actually for the specific heat, right? Or mass or changing temperature, just depending on what's asked here. So because I have my joules here, I actually have my energy for this particular situation. So we got 487.5 joules equals to our, in this case, what is our mass? Our mass is 25 grams, right? 25 grams of copper. So that's what we see here, M. And then, right, we're looking for a specific heat capacity. So that's still going to be our constant in this case. That's what we're looking for. That's our X, right? And then delta T, change in temperature. So it says that we went from 25 to 75, right? So anytime you see a delta, you're going to do final minus initial. Okay, so in this case, we ended up with 75 degrees Celsius and we started off with 25 degrees Celsius. So 75 minus 25, all right? Now from here, it's just all about solving for your specific heat capacity. So once you do 75 minus 25, you're going to have 50 degrees Celsius. Now we just need to solve for our C, okay? And what we do, if we go down here, we're just going to have to divide, right, to get our C by itself. So in this case, it's going to be 487.5 divided by 25 times 50. And then we just do our math, and we're going to find out that the specific heat capacity is going to be 0.39 joules over grams times Celsius. And then we look right at the specific heat capacity for copper. What is it, everybody? 0.385, right? So very, very similar. In fact, the same if you, depending on how many decimals you use, right? The same specific heat capacity for our copper here. All right. So this is how you're going to solve for specific heat. And this is our specific heat equation. So please be aware, if it's asking for specific heat, look for C. If it's asking you for a change in temperature, you're going to have to solve for a change in temperature. If it's asking you for energy, you're going to have to look for energy. Just know how to use this equation.